Before we finish our SDN discussions, let's briefly review two open source SDN controllers. Open Daylight Controller is an open source SDN controller project developed in partnership with the Linux Foundation. ODL has a similar architecture to the general architecture we discussed. It has the SDN controller in the middle. The SDN controller maintains the network state and communicates with devices and network applications. The basic network functions provided by ODL, like topology processing and switch management, are at the heart of its SDN controller. A service abstraction layer called SAL allows controller components and applications to work with each other and use each other's services. SAL also provides an abstract interface to protocols operating between the ODL controller and controlled devices. In addition to OpenFlow, these protocols include SNMP, netconf, and OVSDB, which is for Open vSwitch Database Management Protocol. ODL controller communicates with the network applications using northbound interfaces that include REST, RESTconf, and netconf APIs. These applications include traffic engineering, firewalls, load balancing, and other independently developed functions. Open Network Operating System, ONOS, is also an open source SDN controller project supported by Linux Foundation. Its architecture is even more similar to the general SDN architecture we discussed. The control applications are separate from the controller and run as network applications communicating with it using northbound interfaces. A unique feature of ONOS is support of intent framework, which supports high-level services. This allows a service to ask for a high-level control function like end-to-end connection, without knowing the details of the network provision involved. The main body of the controller, which is called ONOS Distributed Core, is implemented as a set of interconnected servers, providing the service with high reliability and replication for performance scaling. The southbound abstractions and protocols abstract the heterogeneity of underlying supported devices that communicate through the southbound interface with the SDN controller. The move towards software-defined networking started from arguments of separating network layer control and data planes. Challenges of SDN include security, more dependability, and addition of stricter requirements for mission-critical network applications. In the meantime, the efforts toward higher adoption continue. With advancement in software-defined networking, we now have higher acceptance of network function virtualization. Network function virtualization helps in delivering middle box functionalities through SDN, using network control applications. Scaling the SDN control from intra-AS, which is the scale currently deployed, to inter-AS, and eventually bringing it to the internet scale is another path of current research.